Right, guys, this is the second video. The first video dealt with some really basic definitions and how we calculate movement when there is no acceleration, when it is constant velocity. It means you're traveling the same speed from one place to another. But that rarely happens, so let's talk about what happens when you are changing speed. So this is acceleration. Acceleration is a change in velocity. It can be any change. So if we are speeding up, if we're slowing down, if we're changing direction, but our speed is staying the same, then that is all an acceleration. Remember, a vector is something that has both a magnitude and direction. So in this case, in this video, we'll be doing a lot of positives and negatives. That's really our direction. The forward is positive, the backward is negative. In physics, it's very interesting because you can sort of define what is positive and what is negative for you. Generally, the context is somewhat obvious, right? If you're walking forward, then that's usually a positive direction. If you're walking backwards, that's usually a negative direction. But as the situations develop, then it can change and it becomes increasingly arbitrary which one you want to point to. And that will tell you something meaningful about how the object that we're talking about is moving through the universe. So as you can see, velocity is a vector. Acceleration means to change that velocity. Speeding up is considered acceleration, slowing down is considered acceleration, and simply changing the direction is acceleration. So keep that in mind. It's your basic definition. And like always, we have a formula for this. Now, this one has complex fractions in it. I'm sorry about that. It'll go really quick, I promise. So I do want to talk about the units. We talked about meters per second being the standard units of velocity in the last video. This one is going to be meters per second squared, because not only are you changing the distance that you travel each second, you're changing the speed at which you do that every second. So there's two time components, and this is how they fit together in a mathematical sense. So our equation here is our final velocity minus our initial velocity, and that's going to be divided by time to give us a per second acceleration. So you will see these subscripts, final velocity and initial velocity, all the time. Just kind of get used to that. Sometimes instead of an I for initial velocity, you'll sometimes see a 0, and that just kind of means at the beginning of time. It means the same thing, but if you like look online in textbooks, different places, you'll see this maybe a little bit differently. Just kind of keep that in mind. I usually use initial velocity. That seems to be what most people use, and I'm going to continue to use initial velocity just to be consistent. But again, other teachers and sources might do a little bit differently depending on context, so keep that in mind. So as always, t is going to be in seconds. So what does that look like? So our velocity is going to be meters per second. So this is meters per second minus meters per second. Now, if you remember your algebra, you can combine like terms. These are like terms, and so that you can combine them. But we're also dividing these whole things by seconds. That what makes this fraction a little bit complex. So I'm going to rewrite this fraction to get rid of the complex nature of the problem here. So as you can see, I've now combined my terms. So now I have meters per second times 1/seconds. And I'm just pulling this up to that top line. So it's algebraically consistent. You know, if you don't believe me, ask your math teacher. This works, I promise. So 1 times m is m, second times second is second squared. So your units for acceleration are going to be meters per second squared. And you can see, again, going back to what I said in the first video, if you are using different units, then this gets really messy and complicated really quickly. For example, let's say I said miles per hour in this problem. let's say I have a car that is accelerating from 20 miles per hour to 40 miles per hour in 6 seconds. Well, over here, I would now have miles per hour times seconds, which, is mathematically consistent, but it makes the problem unnecessarily difficult. And so you're going to want to be consistent with all of your units. If you see something like kilometers an hour and seconds, then you'll want to convert everything into meters per second or whatever units make sense. Just be consistent with those. Then let's do an example problem. Okay, so this is what you should do. Car accelerates from 20 to 40 meters per second in 5 seconds. What's the acceleration? Now, one mistake that students often make is they will say, okay, 20 minus 40 divided by 5. I can do that, except that that's wrong, right? So we always want to take the final velocity minus the initial velocity, even though in our problem, it says the initial velocity first in words. And that's because that's how we say it in words. But when we want the difference between these two things, we want to make sure that it's 40 minus 20, final velocity minus the initial velocity divided by time. So what is that? That's 40 minus 20 divided by 5. That is going to equal 20 divided by 5, which is 4. I've put the units back in, 4 meters per second. I didn't include the units over here because it would get really super messy. And so 4 meters per second squared, that is our acceleration. What this means is that every 1 second, I'm going to increase my speed by 4 meters a second. So I'm going 20 meters per second over here in the start, and then 1 second later, I'm going to be doing 24 meters per second. In the second, I'm going to be doing 28 meters per second. In the third second, I'm going to be doing 32 meters per second, and so on and so forth, right? So that's what that means. So we're changing our speed every second. That's all it is. Now, let's change this problem a little bit. Let's do the other way around. Let's say our car is accelerating from 40 meters per second to 20 meters per second in 5 seconds. What is the acceleration? Same numbers, but a different scenario, right? If we are going from a high speed to a low speed, we're slowing down, aren't we? So we're going to put this into our equation just like we did before. So our initial velocity is going to be 40. And then our final velocity is going to be 20. So it's 20 minus 40 is minus 20 divided by 5 is negative 4 meters per second. So when we're slowing down, we're going to get this negative acceleration. So a negative acceleration is valid and logical in physics. What this means is that even though your velocity is positive, that your acceleration is going the opposite, right? So your velocity is going forward, your acceleration is going backwards, and eventually you're going to slow down. Right? If we did this for another 10 seconds, then it would come to a 0, right? So what would happen if we did this for more than 10 seconds? Is that a logical result in physics? And it is. Let's look at this problem. The same kind of problem, only instead of 5 seconds, we're going to do 15 seconds. A car with an initial velocity of 40 meters per second accelerates at a rate of negative 4 meters per second squared for 15 seconds. What is the final velocity? And before I continue on this problem, I get this question asked by just about every student who starts on the acceleration. What do I do with this squared? Do I do 15 squared? I don't. This squared here applies only to the units. It doesn't apply to the seconds. It doesn't mean that I'm going to do -4 times -4. It just applies to the units here. Nothing else about this problem. So what is the final velocity? So I'm going to put into my equation Acceleration is equal to the final velocity minus initial velocity over time. And even though I'm asking for the final velocity, I'm just going to keep my equation the way it is and just substitute my numbers. And that's what I've done here. I have had students try to algebraically rearrange the equation first and then substitute. And if that's what you like to do, go for it. I find that being consistent in this way, for me as I instruct, helps students kind of figure out what's going on. So that's just a personal preference on mine. It doesn't matter if you rearrange your algebra and then substitute, or substitute and then solve. It makes no difference. Here we have 15 times 4, negative 4. That's going to be a negative 60. Negative 60 equals velocity minus 40. I'm going to add 40 to both sides. That's going to give me a negative 20 meters per second. So now I have a negative velocity. What's that all about? Remember, a velocity has both a magnitude, a size component, and a direction component. So what this means with a negative number here is that I'm now going in the opposite direction. I've assigned a positive value. So my initial velocity here is positive, going forward, but my acceleration is negative. So I'm accelerating, I'm going slower and slower and slower. I get to 10 seconds, I stop, and then in the next 10 seconds, I start going backwards, and I start going backwards faster and faster and faster. So this negative does not tell me about the absolute speed. The negative tells me the direction in which I'm going. I started out going in a forward direction, but I ended up going in a negative direction. So, and what that means is depending on the context here. So this car has decided that forward is positive. Maybe he's going north, maybe north is positive. And then over time, he eventually ended up going south. Whatever the story makes sense, but this is how we arrange this mathematically. And that is how you do acceleration. I am going to do one quick thing. Time. Let's do some quick unit conversions on time, because I also see students struggling with this. If I have 2.5 hours, what is this in minutes? Or how many different ways can we say 2.5 hours, right? We can say 2 hours and 30 minutes, or we can say this is 1 hour is 60, so 60 and 60 is 120, 120 plus 30, we can say this is 150 minutes, right? When we want to be consistent with our units, we can't have 2.5 hours. This will mess us up. If we want to do a fraction, then the fraction is okay. 2.5 hours, if so long as we're not dealing with seconds, then the hours will make sense. If we want to convert everything into minutes, that's fine. If we want to convert that further into seconds, if that's meaningful to us, then we can do that as well. But let's make sure that we can deal with how do we convert into decimals when we have time. So let's do another with 2 hours and 15 minutes. I can do that in my head. All right, let's convert this totally to hours. Right? What is this in hours, right? So how many times, how many 15-minute sections are there in 1 hour? There's 4, right? So in 1 hour, you'll go from 15 to 30 to 45 minutes to 60, and then you've got an hour, right? So 15 minutes is 1/4 of an hour. So we'll do it this way. We'll do, let's draw this out. Let's do 15 minutes divided by 60, because there's 60 minutes in an hour, and that is going to equal 0.25. And if you want to use the system we talked about last time, which I strongly suggest, it would look like this: 15 minutes. Minutes. And how many minutes are there in an hour? There are 60 minutes. To 1 hour. And that's going to equal 0.25. Again, like this is pretty intuitive, but what if you had something like 27 minutes in an hour? Well, I don't know. It's going to be close to half, but in that case, it'd just be 27 divided by 60. No, or 37 divided by, that's how you convert minutes into hours. If you wanted to do it the other way around, what is half an hour or 0.5 hours the way that we have here in minutes? And we can actually do it all in one step. 2.5 hours. That would be 1 hour for 60 minutes. Notice how my units are canceling out. And then this is going to give me 2.5, again, is 150. So I can, oops. This is going to be minutes. Oh. And I see that I forgot my units up here as well. Okay, so that's how you would convert time. If you're not sure, again, this is a great way to check. And like I said numerous times now, you probably don't have to go through this process for like really simple problems, but the more you practice and do it for the simple ones, the more complex problems will be easier when you get down to it. Okay. That is it for this particular video. I hope that this made some kind of sense for you.